This is APAB. We're doing Intro to BC Calc, topic number 3, which is improper integrals. So what makes an integral improper is that it has either infinite bounds, right? So something that is from 5 to infinity, right? That makes it improper. Or something from negative infinity to 2 makes it improper. Or it has finite bounds, but those finite bounds fall around a discontinuity. Right, so discontinuity, spelling is hard. So this has a discontinuity at x equals 2 because it's got a vertical asymptote, right? And so if you were to integrate from 1 to 3, that's a problem because you're integrating around a discontinuity. So essentially, when we're talking about improper integrals, they look pretty much like normal integrals. You're just going to have one of two situations. Either one of your bounds is infinite, or you're integrating around discontinuity, right? So we're going to go ahead and walk through how we do this. So I'm going to walk you through example 1, and then we'll just kind of keep going. All right, so example 1 in your packet is the integral from 2 to infinity. So in example 1, we're going to do the integral from 2 to infinity of a 5 over x squared with respect to x. So the thing is, if you're doing this as a multiple choice question, I'm going to go ahead and be honest and say that I am a super lazy human on multiple choice questions, and I will definitely leave that infinity as a bound. But technically, that's mathematically wrong. So if you did that on a free response question, the AP is just going to annihilate you for it. So the trick here is that we're not supposed to have infinity as a bound or negative infinity as a bound. We're supposed to have finite bounds. So what we do is we cheat and we use our knowledge of limits. So I'm going to call that top bound B, and I'm going to say that I want the limit as b approaches infinity. And that right there is the big trick. Nothing else drastically changes, but you have to have this notation in a free response. Again, I'm going to own up to the fact that I am as guilty as anyone on multiple choice of just saying, forget it, I'm going to keep infinity and do all the mathing. I get it. It's okay. It's not mathematically correct, but it gets the job done, and sometimes that's what we have to do. So I'm going to go ahead and integrate this the same way I would normally integrate it. Now, the only difference is that when I go to plug in my bounds, I'm going to have something infinite to plug in. Okay, so this is actually a 5x to the negative second, right? So by the power rule, when I integrate it, I up the power by 1, meaning the power will now be a negative 1, because that's 1 more than negative 2, and divide by the new power. So essentially, I'm going to get a negative 5 over an x, right? So when I integrate. So what's going to happen is I'm going to get that this is the limit as b approaches infinity of a negative 5 on top of an x evaluated from 2 to b, right? So when I plug in, that's the limit as b approaches infinity of a negative 5 over b minus a negative 5 over 2, right? So negative 5 over 2 is just a number. That's fine. But when I go to plug in here, what I have right here is a finite number on top of something infinite, right? And that's always going to be 0. So one thing worth noting that I'm just going to add over here for a sec, it is very important that you remember that the limit, as let's say x approaches infinity, and that can be plus or minus infinity, of some number on top of x, or x to any power really, like x to any power on the bottom, is definitely going to be 0. Anytime you put a finite thing over something that is infinitely large, it's 0, okay? So that's really what this is going to come down to a lot, right? Is that we're going to have a lot of like, hey, that's a number on top of an infinity, that's 0, right? So what ends up happening is I end up getting this 0 plus a 5/2, and so my answer is that this integral is 5/2, right? Now, had I gotten an answer that involved infinities, then I would have a situation where what's happening is that we are divergent, right? Or the integral diverges. It does not have a numerical value, and the answer is diverges or divergent, depending on how you want to phrase it. Okay, so that's our example 1 with an improper integral.